Hello and welcome to tcVISION Know-How. Today we show real-time synchronization of DB2 to a big data environment. We use a DB2 table with about 50,000 records and transfer the data via Kafka in a big data environment, from a CentOS 2.1 to a Linux server. Here are the two components, CentOS on the left and tcVISION on the Linux server on the right. We start with the output table on the DB2 v11. It's an item database with about 50,000 records, including the attributes ID, name, catalog number, suppliers, price, and unit, both numbers and characters. Kafka is installed on the server side. We start a consumer that writes the end results in a file so we can look at the processed results afterwards. The processing chain includes a sender that sends the data to the server without processing. The receiver receives the data, processes it, and writes it into the big data environment. Let's start with the creation of the metadata. First, we define the output target. All output targets involving big data have the type big data in tcVISION. The connection string indicates which transport protocol and transport layer are used. We go with JSON and Kafka. These are the settings for JSON. We can modify the output. These are the settings for Kafka. We enter the broker and the topic name. Variables in the topic name let us sort the topics by table or output target name. The output target is created and we can start with importing the metadata. We need an input, an output, and a replication. Our output target is the Kafka 4 DB2 that we have just created. The data is in a mainframe in a DB2. We use the catalog tables. We select the DB2 and select to not import compression dictionaries. The tree structure allows us to select the tables. Here we define the task. Our output target only contains the table name because there are no schemas in Kafka. The import was successful and we can look at the result. Input, output, and the replication is linked between them. As first part of the processing chain, we create a sender. Processing tasks are created in so-called scripts. We enter a name for the script, and define the type. Our task should read out DB2 using the IFI306 interface. Different settings optimize the amount of data that is to be read. We define a connection to the DB2. User ID and password are not necessary because we use CHF. The output should be sent to remote without processing. Our remote output is our Linux server. We select our receiver and select that further data should be waited for at the log end. The sender and the processor are on the server. Here we see that the data is received by remote and that DB2 log recs are contained in the data flow. The output should go to the connection with the input table in the repository. Now we can start the processing. Here we see that the sender automatically starts the receiver and that there's a connection between them. Now for the updates. We perform 2 updates and 1 insert. All 3 were successful and affected 1 row. In the statistic we can see that we performed 2 updates and 1 insert. This was transferred to Kafka in 1 transaction. Let's look at the output using the JSON viewer that shows us the output in a structured way. We have 1 transaction with 2 changes, 2 updates and 1 insert. Of course we can also see the corresponding data. What did we see today? We saw that tcVISION can efficiently use the IFI 306 interface and that it sends the data to the server without further processing, so the CPU load is kept at a minimum. Different transport layers and protocols allow flexible adjustment to further processing in the big data environment. New protocols and transport layers can be easily added because of the modular structure. Thank you for your attention.